Hi, we're now on page 14 of the complex numbers notes, and in the next few pages we'll be solving quadratic equations with complex coefficients. So far you've been solving quadratic equations with real coefficients, and you've been noticing that the roots are conjugate surds of each other. Also towards the end of the last video we looked at finding cube roots of numbers as well. So we know here that we're solving quadratic equations such as this one, and the coefficient of the x squared is real, but the coefficient here of the x is a complex number, so it's got a complex coefficient, and c here, which is the constant term, is also a complex number. So in this case, a is real, but because we know that our we've got ax squared plus bx plus c equals 0, if any of these are complex, if A, B, or C, you only need one of them to be complex, then you'll have to use this method to find the square root, or actually, sorry, to find the roots or to solve the equation. Sorry, I'm just going to focus. Now, what I'm going to do, let's say you were trying to solve this. This is what would happen. You would do x equals negative b, which is negative 1 minus I, plus or minus the square root of b squared minus 4ac, so 1 minus I squared minus 4 times 2 times 1 minus I, all over 2 times a. Now that's what you would do. So if you were trying to solve that, this is what you would do. You'd do negative b, sorry, that's just looking a bit messy. So it's negative 1 minus I plus or minus the square root of b squared minus 4ac over 2a. Now, to work out this square root of b squared minus 4ac, it is the same process as what we did back on page 11. So what we do all that square root of b squared minus 4ac and work out the square root of that first, and then we come back and put in the result of this into the quadratic formula. So don't go and start all this off first. So what you'll do, just find the b squared minus 4ac first. So that's step one. So step one is to find the discriminant first, and then we're going to find the square root of the discriminant. So in steps 1 and 2, we're going to work out the square root of b squared minus 4ac. Okay? So let's start. So the discriminant is b squared minus 4ac, which happens to be 1 minus I squared minus 4 times 2 times 1 minus I. And if we expand that and simplify, we get that it is 1 minus 2I plus I squared minus 8, because it's minus 8 times 1, and minus 8 times minus I, which is plus 8I. So therefore, we know that I squared is negative 1, so we get 1 minus 1 is 0, so we get minus 8, and minus 2I plus 8I is plus 6I. So therefore, my discriminant is negative 8 plus 6I. So that's the discriminant, that's what that equals. Now what we're trying to do is find the square root. So what we're trying to do now is find the square root of negative 8 plus 6I. Now, like I said, that is just like what we were doing on, it was page 12, square roots, all right? So now we want to find the square root of negative 8 plus 6I. Okay, now we do that like the process that we used 2 pages ago. So first we start off by saying, let z, or we can just go straight into it and just say, let x plus yi squared equal negative 8 plus 6i, because we know that they're both z squared. So let z squared equal that, but it's also equal to that, okay? So look, we're trying to find, actually, this is what we're trying to do. We will let z equal the square root of negative 8 plus 6i. In other words, z squared is negative 8 plus 6i. Okay, so I'm just going to solve this all together just to try and save a bit of room. So we get x squared plus 2xyi plus y squared I squared. Actually, you can pause the video and just do this on your own now. Equals negative 8 plus 6i. And we've got x squared minus y squared plus 2xyi equals negative 8 plus 6i. So equating coefficients, real and imaginary, we get that x squared minus y squared is negative 8, equation 1, and we know that 2xy is 6. So therefore y is 6 on 2x, which is 3 on x. I'll call this equation 2. We're going to sub that into equation 1, and we're going to get x squared minus, now I'm going to square that straight away, minus 9 on x squared is negative 8. And multiplying through by, running out of room. Multiplying through by x squared, we get x to the power of 4 minus 9 equals negative 8x squared, bringing everything over to the left-hand side and forming a quadratic. We get x to the power of 4 plus 8x squared minus 9 equals 0. Factorising this, we get x squared plus 9, x squared minus 1 equals 0. Solving that, we get x squared is negative 9 or x squared is 1. This has no real solutions. This has solutions plus or minus 1. So therefore when x equals positive 1, we get that y is 3 on 1, which is 3. And when x equals negative 1, y is 3 on negative 1, which is negative 3. And so therefore, your x plus y i's will be 1 plus 3i, or negative 1 minus 3i. And so therefore the square roots of negative 8 plus 6i are 1 plus 3i, or negative 1 minus 3i. But what I need us to do, we need to write it as a plus or minus. So we've got, therefore, it's plus or minus 1 plus 3i. Now I'll show you how this works. We take the high road and the low road. So if you do the plus, you get plus 1 plus 3i, that's that one. If you take the bottom, you get minus 1 minus 3i. So therefore, if we put plus or minus 1 plus 3i, that gives me both those solutions. Okay? So therefore, back up here in my quadratic, therefore the square root of all of that is this, plus or minus 1 plus 3i. So now we're going to use the quadratic formula. Okay, so use the quadratic formula, in brackets, actually the square root of, instead of just discriminant, can you change this? The square root of the discriminant has already been calculated in step 2 above. Okay, so let's just fix that now. So let's do it. So we've got x is, sorry you can't see the question anymore. So here is our question. So we want x is negative b plus or minus the square root of b squared minus 4ac over 2a. All right, I'm just going to write down here what a is. I've got that a is 2 and c is 1 minus I. Okay, so I've just written that down here. A is 2, c is 1 minus I. So x equals negative b plus or minus the square root of b squared minus 4ac over 2a. So, sorry, I should also write what b is, and b is 1 minus I over there. So therefore, x is negative 1 minus I plus or minus. Now the square root of b squared minus 4ac is this. So the square root of negative 8 plus 6i is plus or minus, we can see it's plus or minus 1 plus 3i over 2 times 2. Okay, again, negative b is 1 minus I if we look at that top equation, plus or minus. The square root of b squared minus 4ac is worked out here, and it's plus or minus 1 plus 3i. So you replace this whole square root of b squared minus 4ac with plus or minus 1 plus 3i over 2 times 2. Now I'm going to expand this, so I've got -1 plus I. Now I've got, you might think there are 4 options here, but there's only 2. You can do plus plus is the same as minus minus. So we just do the plus ones. So we get +1 plus 3i over 4, or expanding this again, -1 plus I. Now, if you do the plus minus, you've got a minus, or if you do the minus plus, you've got a minus. So we do minus these. So -1 minus 3i over 4. So now simplifying that, this is what x is. Actually, I'll just move it up here. And so therefore, I get x is, now I've got -1 plus 1, that cancels to 0. I plus 3i is 4i over 4, or -1 minus 1 is -2. I minus 3i is -2i over 4. So therefore x is I, or these are both over 4. So I should be writing it as a complex number. So I've got -2 on 4, which is a -1/2, minus 2i over 4 is -1/2 I. So therefore, the question is to solve, this is my solution, x is I, or -1/2 minus -1/2 I. Notice I am solving a quadratic equation, so I should get 2 solutions for x. Notice that the coefficients are complex. Okay, so A, B, and C are not all real. Some of them are complex. Notice that my 2 solutions are not complex conjugates of each other. Okay, so I don't have -1/2 minus 1/2 I, -1/2 plus 1/2 I, for example, because the coefficients of my quadratic equation are complex. Okay, so notice the 2 roots are quite different. Okay, so just down here, note that when the coefficients of a quadratic equation are not all real, the roots of the equation need not be complex conjugates. However, the relationship between sums and products of roots still applies. I mean, it is still a quadratic equation, even though the roots were complex. So in other words, relationship between sum and product of roots is sum of roots is minus b on a, product of roots is c on a. So what we're going to do, we're just going to look at the 2 answers that we got, and we're going to do sum of roots. So we've got plus -1/2 minus 1/2 I. Now if we add those together, what we'll do, I'm going to go a common denominator of 2. So this would be, I've got 2i minus 1 minus I over 2. So 2i minus I. So I'm making this 2i on 2. We've got minus 1 on 2, and we've got minus I on 2. So I've got 2i minus I is I, minus 1 on 2. That's my sum of roots, okay? Now, let me look at product of roots. Product of roots will be I times -1/2 minus 1/2 I. And if I expand that, I get negative I on 2 minus 1/2 I squared, which is negative I. Notice they're both over 2, so I'm going to put them both over 2. Now, so I've got negative I minus I squared over 2. Now, minus I squared is plus 1, so therefore I've got 1 minus I over 2. So those are my product of roots. Now, we know that product of roots is C on A, and we know that sum of roots is minus B on A. Now, we know that for any quadratic equation, just leave that. I'll take them off for a sec. I can just go straight to the quadratic. So let me just write out what the equation was, because it's at the top of the page. The equation was this: 2x squared plus 1 minus ix plus 1 minus I equals 0. So if I look here at minus b on a, which is sum of roots, I get minus 1 minus I over 2, which happens to be I minus 1 on 2. That is the same as what I got here for the sum of the two roots that I worked out over there. So that's correct, okay? Now, if I look at product of roots, which is C on A, according to my quadratic, C on A is 1 minus I on 2. Notice that it's identical to when I multiplied what my two roots were that I got up here. So 1 minus I on 2, so therefore that's correct as well. So this is just showing that the answers that I got up here, if I check and do sum of roots, I get minus B on A according to this equation. And if I do the product of those two roots, I get 1 minus I on 2, which happens to be C on A in this particular equation. So therefore I know my answer is correct. Okay, we're now going to go to page 15. Okay, on page 15, you're asked to solve that quadratic equation. Notice the coefficients, or A and B, are complex, but the C is real. But it doesn't matter, as long as one of them is complex, you need to use the method that I just did. So the method is, first find the discriminant. Discriminant is B squared minus 4AC, which happens to be, now you can actually pause the video and attempt this yourself, just following the steps that you did in on page 14, okay? And then restart to check your answers, all right? So B squared is minus 2 bracket I plus 1 squared minus 4 times I times 10. Now, negative 2 squared is 4, and then you're squaring 1 plus I plus 1, so you get I squared plus 2I plus 1. Then we get minus 40I. So we get, now I squared is negative 1. So negative 1 plus 1, that's 0. So I just get 8I minus 40I, which happens to be minus 32I. Okay? So that's what my discriminant is. So next thing we have to do is to find the square root of negative 32I. Now to do that, if we let the square root of negative 32I equal x plus yi, then negative 32I will equal x plus yi squared. So squaring this right hand side, we get x squared plus 2xyi plus y squared I squared. We know that that's negative 32I is equal to x squared minus y squared plus 2xyi. Now again, equating coefficients, real and imaginary. We get that x squared minus y squared equals 0, that's equation 1, and 2xy equals negative 32, equation 2, or that y is negative 32 on 2x, which is negative 16 on x. Okay? Now, you can keep going. You've done this a few times already. So now you can sub that into equation 1, and you will get x squared minus negative 16 on x squared equals 0. So x squared minus 256 on x squared equals 0. Multiplying through by x squared, you get that. Factorizing, you get x squared minus 16, x squared plus 16 equals 0. Solving, you get that x squared is 16, in other words x is plus or minus 4, or we get that x squared is negative 16, which has no real solutions. Okay, now you can continue. Right, you still have to find your y values. So when x is positive 4, from down here, we get that y is negative 16 on 4, which is negative 4. And when x is negative 4, we get that y is negative 16 on negative 4, which is positive 4. And so therefore, the square root of negative 32i is equal to 4 minus 4i, or minus 4 plus 4i. Remember, we need to write it as a plus or minus. 4, you need to work out what it's going to be. You'd have a minus here because we've got plus 4 minus 4i, which is that one, minus 4 plus 4i, which is that one. So now we can use the quadratic formula. So therefore x is negative b, which is plus 2i plus 1. So negative b plus or minus, now the square root of b squared minus 4ac. So it'll be the square root of negative 32i over 2 times a, which is 2 times I. So we'll get that x is 2i plus 2 plus or minus, now the square root of negative 32i is plus or minus 4 minus 4i. So now over 2i. So now expanding this, we've got 2i plus 2. Doing the pluses, you can do the plus plus or the minus minus, you get the same. Plus 4 minus 4i over 2, or we can do the plus minus or the minus plus, gives you the same answer. 2i plus 2, we get minus 4 plus 4i over 2. Sorry, these are over 2i and over 2i. So simplifying this, we've got 2i minus, let's do the real numbers first. So we've got 6 minus 2i over 2i, or we've got negative 2 plus 6i over 2i. Now dividing everything by 2, we've got 3 minus i over I, or negative 1 plus 3i over I. Now, realizing the denominators, timesing by negative I over negative I, or negative 1 plus 3i over I times negative I over negative I, we get, put that in brackets, and this, we get negative 3i plus I squared over negative I squared, or I minus 3i squared over negative I squared. Now, negative 3i squared is negative 3 times negative 1, which is positive 3. I think we've lost an I. Oh, no, sorry, mistake. So, sorry, that's negative, that's not a squared. So you get minus 3i minus 1 over minus I squared is positive 1, or I plus 3, because minus 3i squared is plus 3, over negative I squared again is 1. So therefore we've got our solution is, we're just about done. Well, we are done. So therefore your answer is, you've got negative 1 minus 3i in the x plus yi format, or 3 plus I. So these are the solutions to that quadratic equation. Notice there are two solutions. Notice the solutions are not complex conjugates of each other, and those were the solutions of this quadratic equation. Being a quadratic equation has to have at most two solutions because it's x squared. Okay, so that's that question. Now there is one more example here. Okay, all right, now it says example 3. X squared minus 3 plus I in brackets x plus k equals 0. If 1 minus 2i is one root, find the other root of the equation and hence find k. Now, we cannot say that the other root is 1 plus 2i. Reason is we've got a complex coefficient in this quadratic equation, so you can't do that. So, if one root is equal to 1 minus 2i, we're just going to let the other root equal x plus yi. That's all that we can do. So what we can now do is try sum and product of roots. So sum of roots is equal to 1 minus 2i plus x plus yi, which equals minus b on a. Now, So we've got 1 minus 2i plus x plus yi is equal to, now minus b is minus bracket 3 plus I, so it'd just be 3 plus I over 1. So what we can do here is we can just keep the x plus yi on this side is 3 plus I minus 1 and take these to the other side, plus 2i. So x plus yi is equal to 3 minus 1 is 2 plus 3i. So therefore, the other root is 2 plus 3i. So we've found the other root. Now, we still need to find k. Because k is in the C position, we would do product of roots. So the product of roots is, now we know what the two roots are now as well, so that's even better. So we've got 1 minus 2i times 2 plus 3i is C on A. We get 2 plus 3i minus 4i minus 6i squared. Now C is k and A is 1. So therefore we get that 2, now minus 6i squared is plus 6, and 3i minus 4i is minus 1 is equal to k. And so therefore we get that k equals 2 plus 6 is 8 minus I. And that's the end of the question. Okay, now that's the end of this booklet. So that's the end of page 15. It's all done. So what I want you to do now is to please do exercise 1.1 from your textbook. Please do all of the questions. In case you don't have the book, here is exercise 1.1, questions 1 to 5. I'll drag it down to show you questions, so you can pause the video, just leave it on here or write it down or something. Okay, here is questions 6 through to 10. Okay. Hopefully you can see that. So there's questions 6 through to 10. Okay, I'll just go over to the next page and show you questions 11 to 15. And there are questions 11 through to 15. Now you've got a fair bit of work there, so it's going to take a bit of time. Not sure if you've already got the solutions yet, so if you need anything, just please email me and I can send you some worked solutions, okay?